Hello everyone and welcome to today's presentation sponsored by Seal Aftermarket Products. Let me play you a short product video for
you. Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments, please send your emails to webinars@atra.com. If you have any questions during the webinar, please feel free to text it to me, and I'll answer it the best that I can. This is the schedule for the rest of the webinars this year. The next one will be August 4th and 5th, and that will be on the internal components of the 8L90. This year's expo will be from October 29th to November 1st. It will be held in Rio, at the Rio Hotel like last year in Las Vegas. And this is the schedule for the rest of the seminars for this year that we do around the country. And the next one will be August 8th in Albuquerque. Now, as well as the door prizes that are given away by the vendors, this year ATRA has been giving away our own door prizes. We have one door prize that we give away a complete package to the expo that covers all the seminars or all the management seminars and also the hotel. So we give you the hotel for 4-night stay at the Rio. We also have a management seminar package that you can go to all the management seminars for free. You just have to pay for your own hotel and transportation and expenses. And we also give away 1 month free trial to ATRA Tech, and we're giving away last year's seminar, Expo seminar book. So that's the giveaways that we have at our seminars. Today's presentation is going to be on the U660E and the U760. As you can see here, there's a wide variety of vehicles that these transmissions fit. And as you can see, usually the U760 goes behind a smaller size or lower torque motor. The ID tag is really important on this transmission, not only for ordering the parts you may need for it to get the correct parts for the unit you're working on, but as you can see here, it's also important for this compensation codes. That's a 60-digit alphanumerical values that are printed on the QR label. Now, if the transmission is replaced, the compensation code must be programmed into the TCM. If the TCM is replaced, the existing compensation codes have to be programmed into that TCM. Now, this is done with a factory scan tool, or laptop software, or if you have some kind of a aftermarket compatible tool. Now, if the incorrect information is in the TCM, it could cause harsh shifting. So you want to make sure that the TCM is programmed for the vehicle that it's matched to. This is the trans control module location right there on top of the transmission, plugs directly onto it, and is held in place by 2 bolts. You have the pin ID. As you can see, the pins going into the TCM, basically power and grounds, starting the vehicle, range information, range sensor information, and obviously the CAN bus system. Once we unplug the TCM, we have the pin ID for the case connector going into the trans, so we can do any of our electrical checks to the solenoids or the temp sensor. And also, if you reverse the numbers, you can identify the pins going into the TCM. The range sensor here, the park neutral switch, is located right on top. It's right on top of the case towards the back, right by the differential. And you have the pin ID for that also. And we've given you some resistance checks and parameters that you can do if you want to check out the range sensor. We have 2 speed sensors, turbine and counter gear speed. You have the pin ID for those also, so if you want to do some electrical checks on those. And we have the pressure switch information. We identify each switch as well as the pin ID, and we identify the function to each switch also. Now, there's some last-minute material that's been added, some information that I received just within the last day or so. So you may not find this in your handout presentation, but if you'd like to, in the upper right corner, you'll see that little camera icon. If you click on that icon, it will actually take a picture of the screen and save it as a picture file or JPEG file right on your desktop. Now, you can print that out later. If you'd want an updated handout, you can send your emails to webinars@after.com, and someone there will send you an updated Adobe file. Here's some information I just received from Jeff Farley over at Valve Body Express. He sent me over these photos and gave me this updated information. There's 2 pressure switches that were eliminated in some 2011 to 13 models. There's really no rhyme or reason to which models will or will not have the 2 switches eliminated. So with the one thing we want to warn you here is we don't want to mismatch these. Obviously, the plate has to go with the single hole in it for the 1 switch, and we want to keep the correct plate for the pressure switch with all 3 switches on it. We also have the fluid temp sensor as part of that pressure switch assembly. This is the solenoid identification and function. And we have the SL or TCC solenoid. That's really a 3-way on-off solenoid. And what it does is it switches the B2 brake control apply valve, and it also controls the reverse sequence valve and lockup relay valve. One of the other things that has happened, it's a kind of a computer error. Your handout page or slide may have this chart on it without the text. That was just simply a computer error. And if you want to take a snapshot of this screen also, and it will be in the updated handout material. What I wanted to show here is at the bottom of the note, the computer can inhibit reverse engagement by energizing the lockup solenoid. What that does is it will release the B3 clutch. So without the B3 clutch, we would not have reverse. This is some more last-minute information. If you look at the tip of this shaft, you'll see there's no O-ring or seal here, no sealing ring for the converter clutch. Now, most of the times, if you don't have a seal on the shaft itself, there'll be some type of a seal inside the converter, but not in this case. What we found is the U660Es do not have a seal inside for the tip of the shaft to control lockup. It's actually metal to metal, and I'm going to show you that in a moment. So we want to make sure that this area, there's no wear or problems on the tip of the shaft, because these have enough lockup issues without having any problems with the tip of the shaft being worn. As you can see here, there's no bushings or seals for the converter clutch. Some shafts would actually seal onto a bushing or a seal or a ring. There's nothing for it to seal onto here. What we're showing you here in the middle, on the left photo actually, is the blow up of where the tip of the shaft would come in, and that smooth area is where the tip of the shaft would actually seal against. So since they rotate in the same direction, there's no issues of metal to metal wear that way, but it has to have a good tight fit to have a good seal there. Now, as you can see in the middle here, we're showing you that the problem is not where the lines wear out from the shaft, but the actual tip just breaks off in the converter. This is a real common problem with these. We have plenty of pressure taps on this transmission. We have one for each clutch. We also have one here for rear lube. And we also identify the cooler in and cooler out fittings. On the top of the case is the B1 and B3 clutch. And we also have the carrier bearing lube and the counter drive gear and differential drive pinion lube. Now you see two red lines going to that one. It's because there's an actual tap on the side and one pointing straight up. Now the procedure here is for the check-in line pressure, which is located right there by the cooler line fittings. It has to be at operating temperature. Turn the AC off. You're going to have to monitor the temperature with a capable scan tool. And basically what we would do here is compare the line pressure to whatever clutch pressure you have on one of the other taps, and they should be within 10 psi. That's according to factory specs. I like to see it a little bit lower than that, but 10 psi is what the factory specs say you can have a difference of. Now, this is something I ran into when working with a shop one day. They were working with a U660E. The input drum was completely wiped out, and all they had in stock was a U760. So I put the two drums side by side to see if there was any possible way it could work. And as you can see in the first photo, the U660 is a little bit taller than the U760. But using the drum as a complete assembly, that area will not contact anything in the transmission and cause any issues. So you can actually swap the entire drum. When I placed them side by side, I found that the outside diameter was the same. I also counted the windows, as you see on the right, for the input speed sensor that triggers that sensor. And I also counted the amount of corrugated slots that they have in the U760 drum. The number came out to the same, and the measurement of the windows and the corrugated slots in the U760 drum were the same measurement. Matter of fact, if you put the one shell over the other, you can see there are some corrugated slots in the U660 shell as well, but they match up, and you can easily swap the drums back and forth, and they will both work on either application. Now, obviously, it's not a bad idea to take a U760 and put a U660 in it because it's got a better load capacity. It has 3 clutches, where the U760 only has 2. One of the biggest problems that we see with this transmission is this middle bearing seems to wear out in the case itself. We see the bearing failing, but most of the time when the bearing is still working fine, you'll find that the sleeve is actually, or the race is turning inside the case, and that will produce a fine metal that will hang up solenoids, stick valves. You may take the transmission apart and find no hard part damage, but trying to figure out where this really fine metal is coming from. It's usually from this area. If you check that race, it should not be turned inside the bore. It should be a press fit. The problem is removing the bearing race from the case. As you can see on the left, we have a retainer ring that's in the middle of the bearing race, which is also in the middle of the case right there, and there's no access to it. Now, the reason that we see the wear, and we actually find more of the wear happening towards the rear of the case, or where the bearing fits towards the rear, than we do at the front. And as you can see here on the left, the gear train is pretty hefty. We have our transfer gears. This is usually going to be behind a higher torque or larger engine than the U660. So we have a lot of force pushing those two transfer gears from each other. So that's going to put a lot of load on the bearing as well. But you can see here the entire drivetrain is pretty hefty, and and where the bearing sits right there, that's where the wear problem is happening. Again, these are behind the 3.5 and the 3.7 V6 engines. That's where we're seeing most of this uneven wear problem happening. Now, we took a torch to this bearing race to get it out of the case. We tried cutting wheels. We tried different die grinders, only to find that this is raced hard and it's pretty tough to cut. So the only way we could do it was with a torch. It's not something that we would recommend. We don't want you to damage the case. But at this point, the case is going to have to be repaired or replaced. Now, the reason we took ours out was for demonstration, and we also wanted to measure the area of wear inside the case. Now, the Toyota manuals will tell you that you can just press this bearing out. We tried it, and it was at the point where the case was ready to explode, so we decided to cut the race out. Now, aftermarket sources are actually milling the race out of the case, and then they insert a sleeve, and they're saving the cases that way. If you can find a used case, they're usually around $175. Make sure that the bearing race is a tight fit on a used case if you do buy one. The cost of a new case is about $1,200. You have the part number in your handout. And the bearing is about $83. The reason I put the word new in blue is that's a lower price. They've gone down a little bit. And same thing with the snap ring. That's bought separately. So if you buy the bearing, it does not come with the snap ring. You have to buy that separately. And you have the part numbers in your handout for all three of them. Another internal problem that we're seeing quite a bit is the actual planetary sun gear assembly. And what's happening here is the sun gear is actually walking away from the hub. When you look at one of these that's in perfect condition because it's a press fit, you should not see any splines like you see here in this photo. Once that starts to move, you're going to see that it hits the planet, and that'll start putting metal throughout the transmission. It'll actually work its way out, and the hubs actually start to rub against the balance piston also, and that even puts more metal throughout the unit. There's a simple fix to prevent this problem from happening. Basically, what you need to do, if you're not sure if yours is moved at all, place it on a flat surface. Take a caliper tool like we're showing here, and from the top of the gear to the flat surface should be 2.33 inches. Now, if it's off a little bit and it hasn't caused any damage, we can press it back to where it needs to be, and then we can just basically flip it over and put 4 little spot welds, so we don't have to worry about it moving again, and it should be able to go through warranty without having any issues. There's several complaints we're going to go through here: delay, slip, or no reverse at all. We find problems with these two valves here, the B2 control valve and also the B2 apply control valve. These valves are known to wear, having a lot of leaks in these bores. There are repairs in the aftermarket available for fixing these valve bodies. Erratic or flaring 4-5 shift, it may want to go to fourth, may drop out. This is also caused by a worn control valve. Either the valve or the bore or both are worn out. TCC apply and release problems. May have a shutter, may go in and out of lockup. May have slip codes, may not have any codes, but if any issues with lockup apply or release, the first place we wanted to look at is the lockup control boost valve and sleeve. And we want to look at the lockup control valve. Engagement problems, delayed or harsh reverse. You're working on any of these transmissions, and we've seen the mileage as low as 45,000 miles with problems with the valve body wear. Check your primary regulator valve. Use this material as a guide to take these valves out, look at them, maybe blow the bore and the valve off dry, put it back without any springs. Do the flashlight trick over the worm track, see if you see any light around them. If not, do a wet air test. The best test to check these valve bodies would be using a vacuum test. Now, a vacuum test stand can be bought through the aftermarket. We've also doing an article in Gears on how to make your own. Erratic shifts, or if you take it apart and the B1 clutch pack is burnt, this is a good place to look. And that would be the B1 applied boost valve and sleeve. Obviously, these parts can just be replaced without having to ream the bore. And then if you have any lube issues, bushings turning blue, bearings failing, high temperatures, may or may not have high temp codes. All these concerns are usually caused by the secondary pressure regulator valve bore or the valve itself wearing. These are good places to go to and check. This is something that should be removed from the valve body, not just picking at the valve to see if it's free. Of course, accumulator bores been a big problem with all of the Toyota valve bodies. It can cause harsh shifts, soft shifts, maybe one particular gear. You can go to that accumulator bore and check it. Again, there are aftermarket parts available for this also. This is a big problem we see not only with Toyotas, we see this quite often with ZF transmissions. It could be TCC problems, shift problems, actual clutches burning up, and that's obviously where the bore plugs start to loosen up at the end of the valve bores themselves. So either we have to replace the valve body or repair the valve body. I want to thank Sonax for this photo. The erratic shift concerns or any type of shift problems. This valve here is probably the most common valve to wear out in any type of valve body, whether it's General Motors, Ford, or Toyota. The solenoid modulating valve. This valve controls the pressure to all the solenoids. In a GM, this would be called an actuator feed limit valve. In Ford, it's normally called a modulator control valve. This controls the pressure to all the solenoids. So this is usually the #1 valve to wear out of most valve bodies. Second to that would be anything that regulates converter pressure. And then lastly, the third most common would be anywhere in the pressure regulator valve bore or with any boost valves to the pressure regulator. We have a lot of these that have TCC shuttle 3/4 shift flares. We went round and round with one shop on the tech line. Finally, what we had them do is just flat sand the valve body. We had them install it without the valve body gaskets. You can use them if you'd like to, but if you flat sand everything good and flat and you torque it to specs, that's what actually fixed this one. We couldn't find any valves worn, any bores worn that it needed to be repaired. So the only fix for it was actually flat sanding it and torquing it back together. We've done this with the ZF6 by just flat sanding the silkscreen sealant off the plate. I've done this also with some of the ECAT units, the ones with the two-pan, the large ECATs. And that surprisingly worked well with those too, without gaskets, as long as everything's flat sanded and torqued. This is a no reverse condition after rebuild. We have reverse when it came in, did the rebuild. We have no reverse. If you look over here to the right, we have the SLU, which is the TCC pressure control solenoid, and the SLT, which is the actual pressure solenoid, control solenoid also. Now, these solenoids look identical, but if you take them out and look at the snout, there is one difference between the two. So obviously, if we swap these around, the first thing that will happen is you'll have a no reverse condition. So be careful. Mark the solenoids where they go before you remove them, so that they are always placed back in the correct locations. This was probably one of the first tech calls I ever took on a U660. It was a delayed engagement. It had some shift complaints where it flared or fell out of gear under light load. These molded pistons are known as having issues of shrinking. Now, we actually took this unit apart. The clutches looked fine. They weren't burning up. We actually air checked the clutch pack, and it air checked fine. We took the piston out of the drum, and when we placed it back in, it literally dropped in without hardly any resistance at all. And so, like I said, it did air check fine, but obviously under pressure, and once the vehicle warmed up, it had issues with engagements and shift complaints. So these pistons should be replaced during every rebuild. They are available from OE as well as the aftermarket. This is another shift issue after rebuild. This is a 1-2 slide, and this was caused by a misassembled B1 snap ring and pressure plate. As you see on the right, that's the B1 clutch installed. On the left, what we're showing you there's another snap ring just above the one that holds the pressure plate down. Now, if that snap ring is left out, you'll end up with an excessive clearance in the B3 clutch pack, and then we have an issue with the shift. Now, this could go either way, but most of the times what happens is the snap ring's either put in the wrong place or only one snap ring is installed. Now, when we go to put the B3 clutch in, it's supposed to sit on top of that second snap ring that you see on the left. Once we stack that up, we have the last snap ring to put in, and that's it has little bent tips on it, and that's the location of where the bent tip ends of the snap ring should go. This is quite often on the tech line I'll get a call that the unit's assembled. I have this extra snap ring, and where does it go? That's usually where it gets left out, is right there on that support. Transmission service, we have a drain and fill overflow plug in the pan. And then obviously there's a procedure to get to the fill plug. We'll give you that procedure here in your handout. We suggest to use the Toyota WS fluid. A lot of times we'll get tech calls, and not on just this unit here, but we'll get tech calls on the 960s, the 750s, the 760s, and the complaint is usually transmission running hot. And we'll get told the usual that they're using a good name brand synthetic that's worked fine for them before in these same units without this issue, but for some reason they've got a transmission in their Toyota that's running hot. We have them switch over to the Toyota fluid, and that usually corrects the problem. I know it sounds strange, but if you've tried everything else on any transmission giving you an issue, it's always best to go ahead and try the OE fluid that is designed for it. Now, when the engineers design these transmissions, they're designing the actual clutch paper to work with the steels using a specific oil. It's all designed together. It's all designed behind the software that they use to apply the clutch and to release the clutch. These clutches are now controlled not only during the apply, but the release circuit is also controlled to the clutches. So this is all factors that have to be looked at. Again, if you're having a problem with the transmission and you've been using the same type of oil and not having an issue, before you go removing the transmission or doing anything like that, try using the OE fluid. Now here what we're showing you is we're giving you the fill amount, whether you have a new torque converter, if you're reusing the converter, whether you've had just the pan off or if you've removed just the drive shaft or the valve body. This is really good information because a lot of shops, what they'll do, instead of worrying about monitoring the temperature and checking the overfill, they'll put the quantity of oil that's required for what's been done to it. So if this has got a new torque converter, it's a fresh rebuild, they'll fill up the transmission with probably more than half the amount of fluid that it takes, start the engine up, put the total amount that it's called for, and usually they don't even have to check the fluid level. If you do want to monitor the temperature, because this has to be filled at a certain temperature, and then monitor the oil dripping out of the overfill tube, at that point you'd need a scan tool. You need a capable scan tool that's going to give you that information. Or if you wanted to do like we're showing you here, is go to the data link connector, jumps pin 4 and 13, then using the D shift indicator, you can confirm what the temperature is by just monitoring what the D shift indicator is doing. So the indicator turns off at one temperature, it'll start to blink when it gets to a higher temperature. So you'll know in between the two is where you need to be to check the fluid level. Then the rest of the procedure to remove the fill plug and put the fill plug back, along with the torque. I'm giving you here the OBD2 codes for this transmission, and that's the rest of the list there. I've also included the fail-safe strategy. A lot of times when driving a vehicle and it starts to go to fail-safe and we don't know how the fail-safe functions, we may actually think we're having a problem with a certain gear, because in certain cases, if it's just a turbine speed sensor, putting it in fail-safe, you're only going to have a shift to either first or third gears that's going to be allowed. So you may think you're having a problem with second or fourth gear, only to find later on that that was just the fail-safe strategy. A great example here is you could have no transmission codes. If you have a knock sensor problem, it'll allow the transmission to shift all the way up to fourth gear, and then it'll stop. We also have the fail-safe strategy in the handout for you for each solenoid, whether the solenoid fails on or off. And we also put in the relearn procedure. This is something I strongly suggest. A lot of these later models, anything from around 05 and later, you're going to find that you're going to need a capable scan tool to reset the adapts. If you try driving this vehicle to relearn it, in some cases you may actually damage the clutches that you just put in it. So if you're not sure, check. If your scan tool is not capable of doing the adaptive learn, then you're going to need to tow it over to the dealership or have someone come out to your shop and with the proper tooling to do that, and have it done before the vehicle's driven. That's it for about today's presentation, brought to you in part by Ray Bestis. I want to play you a short video from Ray Bestis, and if you hang out, after that we'll have some time for any questions you may have.
And at Ray Bestis, performance, quality, and reliability are a part of every product.
Hi, I'm Tim Moy from Tim Moy Transmission in Tampa, Florida. I've been rebuilding transmissions since 1975. We have been using the Ray Bestis GPXs and GPZ clutch plates. We use the GPXs in all our Honda rebuilds. We build a lot of diesel high-performance transmissions, and we use the GPZ clutch plates in this application. We also use them on our everyday heavy-duty, hard-working work trucks with great success. I believe these GPZs are the best clutch plates I've ever used. They give us the durability and the performance that we're looking for.
And at Ray Bestis, performance, quality, and reliability are a part of every product.
Now, I was surprised when I first saw this video because I didn't know that Tim Moy was in it. He happens to be a good friend of mine that lives over in Tampa, Florida. He always comes out to the seminars that ATRA does in Orlando. This guy is probably one of the top 5 builders in the world. I mean, he's that sharp. He's a real good tech. So I was a little surprised that I actually seen him in that video for the first time. Also want to thank Whatever It Takes for partly sponsoring this webinar also. And that would be it for today's presentation. There's a nice ad here explaining the parts that are sold through Seal Aftermarket for the U660. If you don't see that in your handout, you can always, again, take a snapshot of this, or you can send an email to webinars@atra.com and get a updated handout. So if there's any questions, please, by all means, text them to me. I will try to answer those best that I can. If not, have a good day. I really appreciate your time, and I want to thank you all for coming. Okay, if there's no questions, thank you again for attending. I hope I see you at the next one, also at Expo. If the webinar ends too soon, just send your questions to webinars@atra.com, and someone there will definitely help you out. Thanks again for attending.